All right, take a look at problem 3 from worksheet 2. So it says a handball of mass 45 grams strikes this hard wall perpendicular with an initial speed of 46 meters per second. So like just straight perpendicular to the wall, and then it bounces right back out. It says, well, it's in contact with the wall. It's only in contact for 0.078 seconds and then bounces straight back at a speed of 39 meters per second. What's the average force that was applied to the handball by the wall? Use impulse momentum to solve. And so you say, okay, let's do our sketch. So you say, all right, we have our wall here. And that ball comes flying in here at 46 meters per second. Okay. They told us the ball has a mass of 45 grams. We are immediately going to change that 45 grams to kilograms and say that's 0.045 kilograms. All right. This is my initial picture. Let's call to the right positive. Okay, I'm going to choose my directions right away and label that on the sketch. Okay, afterwards it's going to bounce straight back off the wall. Okay, and it tells you that it bounces back at 39 meters per second. You say, now wait, that's in the negative direction. Gotta remember to put that negative on there. Okay, when I put it in my calculation, so it's going to screw everything up. Alrighty, that is the most common mistake on this problem, is people forget to switch the sign on that velocity from one direction versus the other. Alright, what average force is applied to the handball by the wall? I know that the time during which it was pressing on the wall, I know that duration was 0.078 seconds. We want to know the force, that average force, okay, that was acting. You say, okay, well, this, I think, is going to be all right. You say we're going to use that impulse change momentum formula. What do we want to make our system? Well, we're trying to find the force on the ball from the wall. So I need the wall to be something outside my system, so it's an outside force acting. My system is going to be just the ball. All right. Do I need to worry about the gravitational force causing an impulse? And you say, not really, because it tells you it goes straight in and straight out from the wall. That gravitational force isn't acting in the horizontal direction. It's not going to change the horizontal momentum, okay, which is what we're interested in. Again, momentum is a vector, so you just have to worry about along coordinate axes. So there we go. So that's it. I don't have any outside impulse. 0 is delta P. That'll be the final momentum of the ball minus the initial momentum of the ball. Always final minus initial with the delta. And you say, hey, neither of those are going to be 0. We were moving there, we're moving there. So we're just interested in, wait, whoa, wait, what? What am I doing? What am I doing? Of course we have an outside force. Our system is just the ball. Holy cow, Dave, what are you doing? Okay, we gotta have that impulse from the wall. Holy cow. Sorry. This is that force from the wall, that average force. That's why I put a dash over the top. It means average. And then times the duration. Sorry about that. That sticks around. Oh my gosh. You see, the momentum, we can split those up into final, mv final, minus initial, mv initial, right? Okay, force times the duration. Okay, we are trying to find this, right? Do we know the duration of the push? Yeah, we do. Do we know the mass? We say, yeah, we do. Do we know the final velocity? Yes. We know the initial velocity? Yes. We are all good, okay? I can move this delta t over and solve. I'm just going to plug the values in as it is, rather than rearrange. I'm kind of in a rush here. So, hey, my F bar, fine, I'll push it over. Let's see, what are we going to have here? So I'm going to have my delta t underneath, okay? I'm just going to push that delta t underneath. So I'm going to have, hey, that mass, 0.045, times the final velocity. Now be careful, it's a negative, it's going in the negative direction. I need that negative there. Minus the mass times the initial velocity, which is positive 46. Divided by that duration, that was a 0.078 seconds. Okay, I'm going to punch that in my calculator, get my average force, and you say, hey, I already can see this term is going to be negative, and then I'm going to subtract this positive, be a negative. I'm going to get a negative answer. Do I want a negative answer for force? And you say, absolutely. The ball's moving to the right. I need a force to the left to change its momentum to the left. Okay, that should be opposite the direction of the initial velocity, for sure. For sure. Okay, plug those values in my calculator. 0.045. 46. And so I got a value that was like 49.04 newtons, okay? So let's just round that off and say I get this negative 949 newtons for that force on the ball by the wall. So the negative direction. Okay, that's it. I think that's problem 3. Okay, that's it.